Hi, in this section, we are going to see these thermal stresses and how these thermal stresses is behave when the temperature is going to change, and it has a different effect on the different material. And the main reason behind of this is the coefficient of alpha. So this coefficient alpha is called as the coefficient of thermal expansion, as well as it's called as the linear expansion coefficient. So on the basis of this coefficient value, the effect of temperature on that particular material is behave in a different manner compared to other material, because those material having the soft kind of material which will be there, so the value of this for this material will be higher, and those material are very hard. In that condition, the alpha value is going to be less. For an example, if you take two example, first is the steel and second is the aluminum. If you take this two example in which the higher value, it holds the higher value for the aluminum compared to the steel. So now we move to the stresses, in which due to the stresses, there just because of that, it generate the strain in that cross section. If you take any cross section, which is hold first is the mechanical stresses. Due to that mechanical stresses, the strain is produced. That strain plus the strain which is produced due to this thermal expansion. This is how the total expansion which is holding these two stress. One is mechanical as well as the thermal. Similarly, if you're going for the strain which is developing that material, it is also hold this two coefficient, which is nothing but mechanical plus thermal stresses. And the basic funda you should understand, the only one equation, if you remember, uh, the other equation will be very easiest for you, because the strain value, which is denoted in this thermal stress, is nothing but alpha into delta T. And you are familiar with this alpha. Delta is nothing but the temperature changes from that initial condition. If you take the initial condition, it was at 30 degrees Celsius. If you hit that material or cold that material below or upper to that material, so that exactly temperature difference. And in this condition, the temperature you have taken in the degree Celsius, you should not convert this temperature into the Kelvin. So only just because if you should keep in this moment, because most of time we have a habit to change the temperature into Kelvin. But here, if you do that, it is going to be effect on your answer. So firstly, the strain value is nothing but alpha into delta T. You should remember this formula, because on the basis of this formula, entire this this section is going to depend on that. Now you see that we know the value, strain value, and strain is nothing but change in length divided by original length. If it is length, because the strain denoted it a different dimension. In this condition, I have taken as a length is going to be changed. It might be a width, it might be a diameter, it might be any other dimension. So if you put in that condition, that strain value change in length, the length and divided by original length. If you multiply with the original length in the other side, which is right hand to this equation. So this equation, you will give this straightforward value of the change in length in that cross section after hitting that delta T temperature difference. So this is how this is going to be calculated. And also, you know the follow the formula of modulus of elasticity, which is nothing but stress upon strain. And we know the formula for the strain. In that condition, if you change the strain into stress, so it is nothing but the stress divided by strain. And if you shift that modulus of elasticity in other side, so it will become stress equal to alpha delta T, and capital A is nothing but your modulus of elasticity. So here you can find out the stress developed due to the change in temperature. Now uh, the stress we have if you come to the stress value, you can easily find out the force in the Newton. And stress can be written in the form of force per unit applied area. So if you multiply by this above equation by area, which will give you the force which is generated inside that cross sectional due to this thermal stresses. So this is how it's going to be generated. And another condition is that if it is not opposing force is not generated there, or it is not restricted. Take an example, like if you take any rod, if you place simple anywhere wherever you find, and it if you not provide any restriction to it, and if you hit that rod, so strain will be there, because it will expand, but there is no restriction from any other side of that rod. So just because of that, the stress is not going to produce in this cross section. So just keep in mind, because gate mostly give the problem in such a way that it should it is quite little bit tricky, because if the condition, if you're not able to understood the condition proper in proper way, so the straightforward answer will might be the zero stresses, because if it is free expansion, in that condition the stress is going to be developed in that cross section will be zero. So you have to focus on that particular problem. If this problem if you come in the gate examination, you should find out first of all that whether it is a free expansion or a restricted heating process. So now we go for the different example in this condition they used to ask. And first condition is the frictionless surface. Frictionless surface is nothing but one solid cylinder rod is there. So which is simply placed on the frictionless surface. There will be no friction. It is simply smooth surface. So there will be no restriction on it. And in this condition, if you try to heat that material, or if you if you cool that material, so in that condition, if you heat that material, that rod, in that condition it will expand. So due to that expansion, its strain is going to change, develop inside the rod. It change its length as well as its diameter, because apart from these two things, we cannot calculate any other. But it has a lot of space, because it is an open space, and there will be no restriction into it. Just because of that, it is there in that rod. There will be no stress is going to develop. So that is nothing but there will be no. We cannot able to find out the stress develop in this rod. If you need to find out the change in the strain in the or strain develop inside that rod, and change in dimension due to the heating process or cooling process. So in this condition, if you want to find out the change in length, so change in length, as we see above the this fourth equation, in which change in length is nothing but alpha delta t into L. And in heating process, if the dimension, the other dimension is nothing but y and z direction, which is diameter of that rod. And if you replace that length into diameter, so it will become a change in diameter equal to alpha delta t into diameter. And there will be no strain, just because of that the thermal strain, due to the this thermal effect, there will be no strain. The strain will be there, sorry, strain will be there, but there will be no stress in this rod. So now we move to the second case. In this case, one end of that rod is going to fix in the surface. So now the rod has one free surface and one is restricted surface. So in this condition, if you heat and cold the surfaces, so in this condition also there will be no restriction, because if you try to heat that rod, it will expand in the diameter as well as the length manner, because it has a lot of open space, and there will be no restriction. So this, as we see in the above condition, here also there will be no stress produced, but only the strain will be there. And in this condition, there will be change in the length and the diameter of this rod. So as we calculate for the above thing, we can apply the same formula in this example as well, and we can find out the change in diameter dimensions. Now we move to the another example in which now this is the there here we come to the restricted, and here the stress is going to generate in this rod. This example in which the both end of that rod is going to be restricted, which is nothing but it is fixed, and between those two restricted surface, the surface is not going to move, and in that portion we have placed this rod. Now it has a length L, and when we try to hit this rod, what will it do? It will apply the, it will get expand, and after expanding, due to that the stresses is going to generate on the surface, and due to that surfaces the compressive forces is going to generate inside it, because once it start expanding, due to the expansion it try to push away the wall. If we try to push away the wall, but we know the third law of Newton, that each and every force has equal and opposite reaction. So that fixed wall is try to apply the same amount of forces on that rod itself. So what will happen, just because of that that rod after getting expansion, it will if that wall is not going to move, so in that condition the compressive forces is generated inside the draw, and it start bulking in the diameter direction. So in this condition there will be no change in the length. Length the change will be zero, but there is a change in the dimension, that is nothing but the diameter. So the total change in length is the change in length will become zero, and from that we can find out the different forces which were generated inside it. So, and then another example also there, if they were given that change in dimension due to mechanical forces plus as well as the thermal forces. So, the total change in length of this rod is going to be zero. So, in this condition, you can find out the value of RA and RB, which is nothing but the forces generated due to the thermal expansion. So we know the formula for the strain, which is alpha delta T. If you multiply with the modulus of velocity, it becomes thermal stresses. Now, if you have a value of thermal stresses, you can multiply with the area, so you will get the value of RA and RB. And in this condition, that RA and RB is in the negative. We assume as a negative, but it is not mentioned in the PPT. But it is compressive forces. Uh, in this way, you can find out the RA and RB. Now we move to the strain which is developed by the this forces. So first of all, you have understood that there will be no change in the length direction, but there is a change in the diameter direction. So what will happen? It is due to the thermal stresses. First of all, the strain is due to thermal stresses, and secondly, due to mechanical stresses. Now we know the formula for thermal stresses, which is nothing but alpha delta T, the strain, and in mechanical way, just because of it is going to be changed their dimension, so we have to multiply with the Poisson's ratio. So if you multiply with the Poisson's ratio to the strain, which will become alpha mu alpha delta T, and if you take the common mu alpha mu delta alpha delta T, so it will become alpha delta T in bracket 1 plus mu. So this is how you can find out the total strain which is developed inside that, and uh, if it is in the cold position, if the temperature is going to decrease, in that condition we have to take negative value, because in that condition the diameter is going to be reduced. So the value of mu that will be positive, but the strain is going to be negative. So you have to keep in mind, if it is heating process, yeah, then you have to add a plus, and if it is it's a cooling process, then the the diameter is going to decrease, and if diameter is going to decrease, then the strain value is negative. So this is how we are calculating the forces and the total strain which is developed in the direction, and the change in diameter in the y and z direction with respect to the heating and cooling process. Sorry. Now we move to the fourth section, which is nothing but a square cross section, which is has a side is A, and the width of this cross section is T. So it is placed in the coordinate, which is x direction, y direction, and z direction, as shown in the PPT. But in this cross section, only one side we have allowed to expand it, because we have restricted, as the hash line shows, that this is where this hash line is present. That hash line is nothing but it is not allowed to expand in that direction. So it is only it can only expand in the z direction and the y direction. So in the y direction, we have a value a. So which shows that the a value is going to be increased, and the in the z direction, the value of thickness is going to be changed if it is the heating process, and if it is the cooling process, that there is a decrease in that dimension. So now we move to the, as we seen the above formula. This is the combination of the total strain is nothing but the thermal as well as the mechanical. So here only thing is the strain is nothing but alpha delta t into 1 plus mu. But if you find out for the particular change in dimension, the strain is nothing but change in the dimension divided by original the dimension. Here the value, the dimension is going to change is a, and if you put in this formula, it will become change in change in the dimension of in the y direction equal to alpha delta t 1 plus mu into multiplication of a, and in the z direction it is nothing but the multiply with respect to the thickness. And in the cooling process, only need to change the sign, which is 1 minus mu. Now, the other condition is will be same, and if such kind of equation you come into the picture, you have to understood that basically the total strain, which is nothing but the combination of these two, mechanical plus thermostasis, because this kind of question they might ask in many time in examination. Previously, they have used this kind of the example, and there might be there are huge chances of getting the same kind of concept but in the different kind of example. So you have to be thorough with this concept. If you understood this concept, there will be no need to worry about it. Now we move to the fifth cross section, which is taper rod, and uh, as we seen in the previous example, which is similarly in this example we have restricted their both end. So first end, where the diameter is d1, and the force is generated in the side as uh, ra, as we have taken, and the other side, which is shows that the diameter is denoted by d2, and the force is generated due to the expansion, which is denoted by rb. And as we seen previously, there will, if you heat this material, there will be change in the stress and strain. So just because of that, the RB and RA is going to be generated, and it has the compressive in nature. So the total change in the length of this cross section is also be zero. So uh, here we going to see that the here you, if you need to find out the value of the RA and RB, as we seen as the previously, that you need to multiply with its area, which is nothing but alpha delta T E into the area is of this taper rod is nothing but 5 by 4 into D1 and T2, and the similar formula as we have used in the change in length for the taper rod, which is nothing but PL divided by A, and in this A, we also put in the same kind of formula, that is nothing but pi by 4 dA into D2. Now we put this and there will be change in the dimension. So if there is a change in the dimension, which is nothing but the thermal stresses minus the mechanical stresses. So the total of this the change in length will become zero, because when there will be, if it is the strain is divided by the strain is developed by the thermal stresses, and the strain is developed by mechanical stresses. So they used to minus each other, and just because of that, it is there will be no change in the length of that object. So in this condition, if you take that the so why we have taken the thermal stresses minus the these stresses due to the mechanical forces. So in this condition, we should understood that the thermal stresses which is generated due to the thermal, which is going to be higher compared to the your mechanical stresses. So just because of that, we have minus this thermal stresses from the mechanical stresses. And if you put the formula in this condition, though, it will become alpha delta t l minus pl, that pl divided by area into e. And in this condition also, you can find out the this total force is generated by this thermal expansion. And if you find out this p value, which is nothing but the combination of ra plus rb. And now they used to ask to find out the maximum stresses which were developed in this rod and minimum stresses developed in this rod. Because if this question, this kind of cross section will come, the definitely they will ask this question, because it has a special condition. So in that condition, it is nothing but the alpha delta t we have known, but the area, the stresses we have to multiply with da1 divided by da2, because the maximum stresses which is going to be generated at the lower cross section. So if you want to remember this formula, you should keep in mind that smaller is the section, higher will be the thermal stresses. If the smaller higher bigger will be the cross section, there will be less stresses in that cross section. So if this formula is going to ask, you should keep in mind that if you while multiplying with d values, the if it is asked for the maximum stresses in this condition, you have to take d1 first, and after that d2. And in the minimum stresses, in which d2 will be the first and d1 will be the second. If you and if you remember this formula, there will be the ratio they wish to ask to find out the ratio, the stress ratio between maximum and minimum for this taper rod. So which is nothing but, if you remember this two formula, you can directly go for this. Otherwise there will be d1 divided by d2 raised to the square. So this way you can remember this formula as well. But I'll suggest to go for the this two minimum and maximum stresses value, if you remember this, because most of time they used to ask only this. Now we go to the most important cross section in this section, which is nothing but the partial and permitted and shrinking yield support, which is nothing but it has given some permit to expand, because it gives some space between these two wall. Otherwise it will show that this one support, after touching once it start once it touch that wall, the support of that wall is going to be expand in the other direction. So that small space which is available in between that two wall, we used to called as the permissible strain. And the total strain is going to be developed in this cross section. The strain is nothing but the permeable, that shows that the wall, the amount of wall we are going to allow to pass, allow to move. And the other thing is the gap between this. So you can take a note of this, that change in length due to the thermal stresses, which is equal to the gap between this gap between this wall and the rod, and the permissible strain in that rod. So now, if you know the thermostasis formula, which is nothing but alpha delta t into L, and if you move this gap, which is denoted by delta dash in other side, which is the left side, so it will become alpha delta t minus L. So this is nothing but your the permissible stress, permissible strain which is developed inside that rod. And if you want to find out the change in the permissible strain in this rod, which is nothing but the permissible strain divided by original length. So in this condition, if you put this above formula in this permissible strain formula, the alpha delta t into L minus del dash divided by L. So if you, and you are very well known that if you find out the value of strain in this thermal stresses, you can find out anything. So now we have a formula for the strain. Now you apply with multiply with the e value, then we can able to find out the stress value. If you multiply with this above formula with respect to area, so we are able to find out the stresses due to the thermal strain. And there will be another condition, if this thermal stresses is not sufficient to touch the other wall. So in this condition, it will not generate any stress in the edge, because as you seen, there is a change in small gap is available. But when you apply the thermal stresses on this rod, but it is not sufficient to cover up that gap in between. So if it is not able to cover that gap, and uh, if it is not able, then it will not provide any restriction to the expansion of that rod. And if there is no restriction, there will be no stress is going to develop in this rod. So this condition you should check first, if you such kind of question, if you got in the examination or any test series. So mostly test series you will find out this kind of example. So they were used to check their your conceptual, that whether you have thorough with your concept or not. Now we move to the our next case. In this case, it has a two concentric tube or rod. You can take the above, which shows that other above, it has steel tube, and inside it holds the aluminum tube. And it is fixed in other side, as well as it's bolted. You can take an example that it hold the plate in other side, and it has a equal length of these two tube. Only thing is change their dimension, because as you see in the above side, it has a bigger dimension. Or you can take it has a three, this example is similarly, it is used you can imagine it's a tube, as well as you can imagine it's a rod, uh, which is shows that if you take an example for the rod, it holds the two steel rod and one aluminum rod. So you're very well familiar with that. If it is the value of alpha is going to be high, then there will be more expansion. So what will happen in this condition, when you apply high temperature to this rod, the expansion in the aluminum is going to be high, because it holds the higher value of alpha. And what will we do, it will apply the force on the plate, end plate, which we have hold this three rod each other. So once it start applying the pressure, what will it do? It will expand larger compared to the your steel. And due to that, the more stress is going to be apply on that plate due to the aluminum. And due to that, it will get compressing kind of forces. And just because of the expansion in between the steel is less, so it has space. The force is generated due to the aluminum, which tried to pull the steel rod. So just because of that, the tension force is generated between the steel, and the compression forces is going to be generated in the aluminum. So you should not focus on this, just focus on the value of alpha. Because if you know the value of alpha, you have to compare with these two value. If there the alpha value is higher, so it is nothing but definitely it's going to be in the compression, and if the alpha value is less, so you should be you should be clear with that, it definitely going to be in the tension condition. So here the higher value of alpha is going to be for the aluminum. So definitely it is going to be in the compression zone. So in this condition, you have to take negative value, and for the alpha that which hold the higher value of alpha, you should take as a positive sign for that. And the total strain which is produced in this two rod, the amount of strain is produced in the steel, which is equal to the amount of stress which will develop in the aluminum. So that is nothing but total change in length in uh, the steel rod equal to the change in length in the other rod. So how this force is going to be distributed, because this force is applied at the aluminum, which is distributed into the steel rod. So you can take the one relation, which is 2ps equal to 2p, that pa. PS is nothing but the forces due to the which is generated inside the steel rod, and PA is nothing but the force which is generated at the aluminum rod. Now here the other example where we have taken the total change in length of that rod. Both the rod is same. So first we take the steel. In the steel condition, we have a positive sign because it is in the tension condition, and we know the total strain which is developed is nothing but a change in length due to thermal stresses per mechanical stresses. Now the thermal stress is nothing but alpha delta T and L, plus due to the mechanical strain, it is nothing but PL divided by E. Now the same formula you have to take for the aluminum, but only thing is changed here is negative sign, because the went to the compression zone. uh, there is another equation you can find out, that stress in the first section, multiplication of area of that cross section equal to the stress in the other section into the area of that other section. You can take one side as aluminum and other side as your steel. So this is how you have the three equation, which is first you can find out with respect to force, second you can find out with respect to change in the dimension, and third with respect to these forces. So most of time they used to find out, used to ask the find out the forces develop in the both. That first they used to find out the for the steel, and the forces develop in the aluminum. And this combination is they used to call as the parallel combination of two material. Now we have to move for the another case, which is nothing but the compound, but it is in the series combination. So here it is it it this rod is the combination of two material, and which you can clearly see in the right side of this PDF. So there both the end is going to be packed, and the bigger section it has a different material, and the smaller section it has a different material, and they are fixed each other in these two fixed walls. And due to this expansion, there will be this generated in these two forces, that RA and RB. So we are very well known that the total forces is equal to be zero, that RA minus RB equal to be zero, and the total change in length in this condition will be zero, because if the thermostasis is going to the strain is going to be generated in this condition, so it will one material will expand larger, and it will compress the other section. So this is how they will compensate each other, and the total effect of the effect for the length is going to be zero. So in this condition, the same formula is going to be applied. Nothing is changed, same thing, each and everything is same. Only thing is you can take there will be no change, because the total length the total change in length in the boat thing is going to be same, because if you take the combination the emitting section of that two material, So if one material which has a higher alpha value, which will expand more, so it will shows that the change in dimension which is large and which is positive value. But other section which is not going to be expand in the large manner, but due to the forces of this other small the other expansion material, so it will start compression, and due to this compression the change in length of that rod is going to be reduced, and we have taken as a negative value. So if you combine these two together, there will be no change in the dimension, and from this dimension we can find out the your pressure, the forces were generated at the wall. So this is how this is how you can go find out the total change in this stuff, and this is very helpful. And here we have ended with this section. So now we here I have taken a few example, which is uh, which is very simple, and most of the time they were no used to ask, but there might be a chance to ask, because there will be no guarantee of any question that might they will not used to ask. It's simple concept, but you will get if you get to know that, it will be helpful for you. When you apply the forces at the tensile forces at the rod, which shows the parabolic pressure distribution, because if it hold the entire diameter, if you apply the tension forces at the center of that rod, so what will happen, the maximum forces which we are going to apply, which is stress strain which will develop at the center will be maximum, and it will reducing in the upward direction. So it will be not same, but we have assumed that this total strain produced in the entire rod is going to be same, but in actual condition there will be no same, because it varies from the diameter to the radius. uh, in this formula, other formula I have taken, which is for that stiffness. Stiffness is nothing but force per unit change in length, and this formula is very very important. And you the change in length, because if you take the stiffness of this any rod, because each and every material act as a spring, and if it is act as a spring, that shows that it holds some value of k, which is nothing but the stiffness value of that particular material. So in this condition, if you ask, if anybody is asked the what is value for the previous cross section, so there if you there you are able to find out the forces generated inside that rod, and you if you find out that, you can find out the separate change in length of that cross section. So if you get this two value, you can find if straightforward, you can jump to this formula, which is you can find out the stiffness of the particular cross section. So this is how you can find out. And for the diameter, there is a rod, you can which is nothing but ae by l. In simple manner, if you put this delta value is pl by ae, so p is nothing, p and f get cancelled, and this formula will turn out to be ae divided by l. And change in length is depend on the value of cross section of area. If the cross section of area will be higher, then there will be less change in the length of that cross section. So, but the change in length will be going to be low, but the dimension of that going to be high, and it will add the more weight into the your application. So it is not preferable. The second condition is the value of E is going to increase if you take the e value, and its higher value, so in that condition there will be no there will be very low change in length of that cross section. For an example, if you take two rod which hold the same cross section, and if you try to pull that, so one is a steel rod and another is the aluminum rod. In this condition, the e value for the aluminum will be less. So in this condition, the change in length in that will be higher, and they still have which hold the higher value compared to the aluminum. So same material, the different material but same dimension, in which the change in length in the steel will be low. So this is why we go for the steel. And now we move to the another concept where it does it shows that one taper rod will be there, that rod is there, different cross section which is combined together, and it form a series compound rod. So first it hold the D1 length L1, D2 L2, and D3 LT. If we apply the pressure P at the other end of the cross section, and one other end is fixed. So in this condition, there will be change. The total change in this cross section is nothing but the combination of change in length of these three separate cross section. So the force is going to be developed in this cross section, which will be equal to the value of P, uh, which shows that P equal to P1 plus P2 plus P3. And uh, in this condition it will be remains constant for the all three condition, because if you take the cross section, first cross section, there will be only P value is going to apply on this section. If you take the second value, it is only the P value is going to apply this cross section. And if you take the D value as well, there same P value is going to be generated on the fixed surfaces. So in this condition, the value of in the three cross section will be remain same, but the change in length in the due to the change in dimension, that change in area of this cross section is going to be changed, because we are above seen that the area is very much important, and in this cross section the area of these three cross section is different. So more change in strain is going to be produced in the smaller diameter, which shows the smaller area. So smaller area maximum, there will be change in the length. So you can check with the in a normal manner, that if your change in length of the smaller diameter is going to be higher than small. If it is not in this way, there will be some problem in your solution. So this is how you can check with your exam, do your answer and verify with respect to that. Now we move to the parallel connection. In this parallel connection, what will happen? In this connection, they have taken this one single rod, but it hold the in between pressure, that force we are applying is which is at the center of this rod. So it divided this section into two section, which is AB and BC. It might hold the same length or different length. So but the diameter will be same. So the total force in this condition is generated will be same. Okay, yeah. And due to applying this P force at in between this cross section, which is at B position, which hold the same some portion of AB cross section, and some portion of B cross section. If you pull that point at B point, so what will it do? It will apply the compressive forces and in B and BC section, and similarly the same amount of the tensile forces is going to generate in AB cross section. So the same moment, if it is if it is hold the same due to the same cross section, and if it is the same cross section, which is shows that it is made of the same material. So due to the same amount of compression and tension, it will generate the same amount of the extension in the compression manner and in the expansion manner. So due to that, change in length of AB cross section will become equal to the change in cross section of BC section. Only the difference is that the cross section in BC will be in the decrease in the dimension, and in the AB cross section, in that condition the change in the length is positive. So now this is the another example, in which example they used to tie a horizontal rod with two rod or many other rods, and one different rod they used to pull that two rod, and another end of this rod, which is placed at the any hinge point. And if you in that condition, if hinge point is there, so it is not able to move in up and down direction. It is allowed to take a turn about that point. So momentum about that point is possible. So you have seen this is we have taken as a notation for this different point as A, B, C, and this is the actual condition when that cross section is holding up but due to this applying F forces, which is applied in between that B and C point, which is denoted by F value. And when you apply this F value to this to this horizontal rod, it moved down, and the new direction, which is shown by a dotted line, and which is now the ABC, it's moved to the AFG position. And due to that, the force, the extension of that two cable, which is BD and CE, the extension is denoted by BF and CG. So now, uh, here we used to apply the one small concept which we used to call as a triangle law. And if it hold the same one side, then we can find out the other different side of the triangle. Now you can take one triangle in this section. You can easily see, which is A, B, and F, and another triangle is A, C, G. This is two triangle which hold the same A and C line. So from this line, you can find out the change in dimension of this two, because first, if you take the momentum about this A point, so moment is nothing but the force is generated in the BD cable, and the force is generated in the CE cable. So if you take the moment about A, here I have taken that force due to, I have taken the notation that PB. PB is nothing but the force that generated in, the tension is generated in that cable, plus the it hold the 1 meter length from the A point to B point. Now you move to the B to C point, so it will be taking 2 meter length, and the force is generated at the cable CE, which is nothing but denoted as a PC, and equal to the P, which is equal to 1.5, because till B point it is 1, and after that it is in between the 2 point, which is BC, which is 1 meter apart, so it will become zero point 0.5. So the total distance of this F force from the cross section of A is equal to 1.5, and the force F I have taken as a 1 Newton. Here, if the value of F is going to give in different, so you have to multiply with that value, and from that value you will get relation between these the tension of this two forces cable, that PB and PC. Now we want this two unknown and two equation. So another equation we can get out of this triangle law. So here, BC divided by BF. Now the similar manner, if you apply the similar triangle law, then it will be AC divided by BG. So AB we know 1 meter, and the AC we know it is 2 meter. Now the change in dimension of change in this cable length at B to F and CF. Here we get the relation in between two, and from this two relation we can able to find out the total force generated in that two cable, and the amount of deformation which were taking place in that section. So there is another one example they used to ask, and which is stress due to shrinking, and this example in which they used to give application for the tire fitting. So when you try to fit the tire, in which the first you have to expand this tire, and due to the expansion, which is hold the ring. So that ring, if you apply the tire on that ring, so due to the tire, it create some shrinkage in that rim. So capital D is your your rim diameter, and D is your tire diameter, small d. Capital D is rim diameter, and small d is your this another diameter. But and the strain, tensile strain, which is developed inside the tire, which is nothing but pi d minus pi d divided by pi d, and this pi small d is your tire. So the total strain, which is nothing but the change in diameter divided by original diameter of the tire. And the if you get the strain in this condition, you can find out easily the stress which is developed, which is nothing but the multiplication of capital E value. So here you will get the hook stresses develop inside the tire. So this is how we cover this cross section, and now we move to the another uh, concept. In this concept, what they were used to ask that if there will be dissimilar material strip, one is copper, another is steel, and it form as a sandwich kind of cross section. So in this cross section, if you try to heat this cross section, what will happen? What exactly the effect on this kind of sandwich kind of cross section will which will going to yeah, going to make a effect on this cross section. So what will happen if you hit this section? Now you have seen that the alpha value of copper is quite higher than the steel value. So what will happen? The cross section of the copper is try to expand in the larger manner compared to the steel value. And you know the basic concept that if is the alpha values will be high, then it will hold the compressive forces. And due to compression, uh, there will be it will try to push the your in cross section, and it will try to move, and its compressive stresses, due to which the tensile process which is developed inside the steel raw. In another condition, if this condition is for the heating process. If it is the cooling process, which is exactly reverse happen in this condition, in which the alpha value which is higher, which goes to the tensile stresses, and which hold the higher value, which go for the compression forces. And I don't know where they used to apply this Brinell hardness number, but it is mentioned here. But so it is might be applicable for somewhere. So the Brinell hardness number is nothing but 2p divided by pi d in bracket d minus under root d square minus small d. And here p is the standard load, which we used to apply in the kg, and capital D is nothing but the steel ball which you used to press against that material. And the d small d is nothing but the indentation which is generated on that surface. With respect to, we are going to find out the value of that. This is how we're going to find out the thermal stresses, and the deformation of the rod in between due to the tensile and compressive forces. So today we will stop here, and we'll continue this lecture in the next lecture. And we will in that lecture we will going to see that the different application and different example in which how this force is going to apply, and the shear stress and strain which we are developing this and there are few concept which is related to the area and modulus of stiffness. It's combination of that, and stress and strain in the bolt where it going to perform that stress strain diagram, in which the value we have to find out the modulus of elasticity, as we have seen before, but we'll go into detail, and we'll see here. So today I'll stop here.